Hey folks, and welcome back to our video series on physics. We're still looking at basic algebra concepts that we're going to be using a lot. So first off here, we got elimination method. This is the last method we're going to be looking at as far as how to solve a system of equations. A lot of my students find this one to be the nicest. It basically revolves around a concept that we can add equations together. It's kind of crazy. It's really easy to do if it's written in what's called standard form. Now, we usually want slope-intercept form, especially in 8th grade. In 8th grade, the big focus is really on that slope thing. We're going to get more into slopes later on when we start getting into the heart of physics. We start talking about things like velocity and acceleration, which show up as slopes and graphs. But for right now, when we're dealing with an elimination method, what we really want is to have both variables on the same side, because we're literally going to combine them together. So we want like terms to be around each other. This is actually what's called standard form. So standard form is ax plus by equals c. I've got both these equations in that format. X plus 2y equals -4. 2x minus 2y is -5. I'm going to combine these terms. If you notice, I've got 2y and -2y. So if I combine 2y minus 2y, I'm going to get 0. And one of my variables is going to disappear. And that means I can then solve for the other variable, go back, solve for the first. Okay? That's the idea. So literally here, we are adding these equations together. I'm going to add x and 2x. I get 3x from that. 2y minus 2y is 0. And -4 minus 5 is -9. I now divide by the 3, and I get x is -3. All right, now I'm not done. It's a system of equations. We've been dealing with these for a while now, so we know it's an ordered pair we're looking for. We erased y from existence in the beginning. But hey, now I know what x is, so I can go back and solve either equation. It really doesn't matter which one you choose. I usually choose whichever one looks easier to me. So I'm going to plug that -3 in for the x, and I'm going to isolate my variable by adding 3 to both sides, and then dividing by the 2 to find that y is -1/2, and my solution is -3, -1/2. So let's give a couple more tries here. We got x plus y is 4. We got 2x minus y is 14. I'm going to combine these two together. Notice that I got a positive y and a negative y. They're going to go away. I got x plus 2x is 3x. 4 plus 14 is 18. And now I can divide by the 3. Isolating my variable, finding that x is 6. I'm not done. You're going to think you're done right there. I know you're going to think you're done right there. So many of you are going to stop right there, and so many of you are going to get half credit because you stopped right there. Don't stop right there. You got to keep going. You got to go back, and you got to take x equals 6, and you got to plug it into either of those equations and solve for the y. In this case, it's really easy. You subtract the 6 off, and you end up with y equals -2. Over here, we got 3x minus 3y equals 6, and 3x plus 3y equals 0. Notice that we keep having the same value on the coefficients. There's positive and negative. So it's a -3 and a +3, and they cancel out. That's the idea. That's kind of what you need to happen for elimination to work. So when we combine these two, we get 6x. We get 6, we're going to divide by the 6, and we're going to get x equals 1. We go back in, we plug the 1 in for the x, and we get 3 plus 3y is 0, 3y is -3, and y is -1, which means our solution is 1, -1 there. Now, what happens when the variables don't line up? So here we have an example wherein the things don't line up. So are we just out of luck with elimination? Is this so limited? Well, it turns out you can actually multiply an equation through by a number. As long as you multiply every single term, you end up with the same equivalent equation. So an equivalent equation to that second one would be if I multiplied everything through by a positive 3. Okay? If I did that, I would have a positive 6y and a negative 6y, and then I could combine these and get rid of the y's. You have to combine in such a way where one of the terms vanishes. Otherwise, there is no way to solve this. Okay? So I'm going to multiply through by the 3, and then I combine the terms. So 6y minus 6y is going to go away. We got 15x plus 3x is 18x. We got 42 minus 6 is 36. I'm going to divide by the 18, and I'm going to get x is 2. If x is 2, I go back in, and I'm going to solve for y there. So 2 times 3 is 6. I subtract the 6 off of both sides to isolate the variable, and then I divide by the 6 on the y to get negative 2, and my solution is 2, negative 2. Another one here, we got 6x plus 3y is negative 7. I got 3x minus 5y is 3. So looks like x's would be easy to get rid of if I multiplied the second equation by negative 2. Let's do that. I'm going to multiply through by negative 2. I got to multiply every single term. Don't forget to multiply the terms. Now this one's really tricky because notice you got a negative 5y times a negative 2. You got negative 2 times the 3x, so all the signs are changing around. You got to be really careful, guys. You got to watch the little details or else you won't get the right answers. That's the number one thing with math is if you're not looking at the little details, you will make mistakes. Okay? Little things like negative signs can make big errors within something like this. In fact, it'd probably not be solvable or it'd be really absurd. So now I got 6x and negative 6x. I can subtract those and get 0. It's going to give me 13y and negative 13 there. So I divide by the 13. I get negative 1. I'm not done yet. I got to go back. I got to solve for the x. And I find that x is 4/6, otherwise known as 2/3. My answer is 2/3, negative 1. All right. One more try here. We got 2x plus 3y is 10. We got 4x plus 7y is 12. The top one, multiplied by negative 2, would get rid of the 4x. So that sounds good to me. I multiply every term through, and then I combine them. Now this one combines really nice. 7 minus 6 is just 1y, and I'm left with y is negative 8. I plug that y in, and I can get the 4x by itself, and then divide by the 4 to find that x is 17. So 17, negative 8 is the solution there. Now, all those examples have been where things line up still, in a way, right? We had a 4 and a 2, so I just multiplied by a negative 2 to get the negative 4, and they went away. Here, I don't have that. So here, I need to multiply both of the equations. So there's actually multiple ways you can go about this. Ultimately, you could target the x's or the y's, so you're going to have to make a choice. Neither is correct, right? Both are equally valid. There's no one way to do the math problems. As you get further in math, you're going to find that there's more possible choices that are equivalent. Sometimes they're not as nice, though. Okay? You can multiply these through so that the y's go away. You can multiply these through so the x's go away. But one of those ways sometimes is really ugly, and the other way is really nice. So you're going to have to develop some sort of number sense to be able to see that. Don't worry about it now. That actually comes with a lot of practice. That is why we practice math problems. So ultimately here, I'm going to pick a variable to get rid of. I need to make sure that I have opposite signs when I'm getting rid of them. Again, there are at least 4 ways of going about this one that I can think of off the top of my head that are all pretty much equally the same. So I am going to pick one here. I'm going to go for the X's. Ultimately, I am trying to do the same process as finding a common denominator. Okay? I'm going to multiply the top equation by 3. I'm going to multiply the bottom equation by a -4. I chose negative 4 because it's going to give me a negative 12x. I could have just as easily gone for the -3 up top. That might be a little bit harder for some folks because you got a -6 times a -3. It really doesn't matter. Okay, there's multiple ways to solve these. You and your table partners might find that you chose different routes, but you get the same answer. So that is A-okay, and that's going to happen with systems. Especially if you're checking your work, you might see I took a different path than you. That is fine. It's not one way written in stone. So let's distribute these. I got 12x plus 15y is -18. I got negative 12x minus 8y is -52. I combine these down to get 7y is -70 and y is -10. I got to go back and solve either equation. I use the original equations. I don't try to mess with the equations that I've modified. You make less mistakes that way. And I plug in for the -10. I get the 3x by itself and divide by the 3 to find that x is 11. And I write my answer as an ordered pair. All right, so yesterday we talked a little bit about dependent and inconsistent systems. Those were the ones that have infinite solutions or no solution. So what do those look like when we're doing it with algebra? Okay, doing it with algebra, it shows up in some interesting ways. So here we got x plus y is 4 and 4x plus 4y is 16. If I multiplied the top equation by 4, I'd have the exact same equation. Do you see that? 4x plus 4y equals 16. That would be the result of multiplying all those terms by a 4. So I'm going to do that. And then I'm going to multiply the other equation by a -1, because why not? And when you do that, they all add to nothing. All the terms cancel out. So 0 is 0, which is true. 0 is 0. That means that those equations are the same equation. Remember I told you could multiply an equation through by any number you wanted as long as you multiply all the terms, and you'll end up with an equivalent equation. That's what we came up with here. Okay, and those two equations are the same, so they just cancel out. Over here is the other case. We got 12x minus 4y is -20. Negative 6x plus 2y is 16. So I am going to multiply the second equation by 2. When I do that, all the variables disappear. But all the constants didn't. I'm just left with 12. So 0 equals 12 is an absurdity. It's not true. Because it's not true, the system's inconsistent, the system will never meet. Those are effectively parallel lines. Okay? Those two lines never ever meet. There are no solution to that one. There are endless solutions to the other one on the left-hand side. And that's about it. So those are 3 methods for dealing with systems of equations. All 3 of those methods are going to be looked at in terms of motion problems over the next few days. So stay tuned for that, and I'll see you in class tomorrow. Bye.